Hey guys, this is AJ back again. In this video, we are going to talk about how to construct a heap tree. So, how to convert a tree to a heap tree, or when does a tree call a heap tree? There are two conditions for that. Let's see what. The first one is structure and the second one is ordering. So let's talk about structure first. If we address the structure, a tree must be almost complete binary tree. In case you haven't seen my video on an almost complete binary tree, the link is given below in the description. But let's just quickly revise. ACBT have two properties. So if we try to draw an ACBT, let's see. So can this be called ACBT? No. Why not? Because before filling the level number 2, here we moved on to the next level. In order for this to be ACBT, we need to fill this level. So first we fill all the levels and then we move to the next level. Now this can be called an ACBT. So this is the first condition for ACBT. Go to the next level when the first level is filled. Now the next thing for ACBT is we need to first fill left child and then we move to the right. So we start filling from the left. Let's see an example. So do you think this can be called ACBT? No. Why not? Because we need to start filling from the left. So this was the element that was supposed to come here. First this and then this. So we start filling from the left to right. This is the second condition for ACBT. The second property is ordering. So guys, there are two kinds of heaps. For max heap, all the parents should be greater than the child. And for min heap, parents should be lesser than the child. Let's see how. Let's first try to draw a max heap. Now this is an example of max heap. First we need to see if this is an ACBT. So this is a valid ACBT. Why? Because all the levels are completely filled, if you see, and we started filling from left to right. Now let's see why is it a max heap. Because every parent is greater than its child. If you see, and guys, one thing you need to remember that this applies to every node, not just to the root parent node. So if we see 15 is greater than 10 and 13, well and good. 10 is greater than 5 and 8 and 13 is greater than 12 and 11. So this is an example of valid max heap. Now let's see min heap. Now guys, this is an example of min heap. Why? First we see if this is an ACBT, this is a valid ACBT. Moving forward, every parent node is smaller than its child. Let's see how. 50 is smaller than 60 and 75. Now moving to the left side, 60 is smaller than 65 and 70, and moving on the right side, this parent 75 is lesser than 85 and 90. Let's try to further clarify the concept using some more examples. In this example, let's try to find out if this is a max heap or a min heap. Before that, you need to check that if this is an ACBT. So let's check. This is not ACBT. Why? Because before filling this level, we said in ACBT we start filling from left to right. So instead of start filling from 3, we started filling from 4. So this is not a valid ACBT. So we cannot call it a heap. Let's see another example. So guys, let's see this example. At first glance, this looks like it's max heap. But it's not. If you see 20 is greater than 15 and 18, okay, good. 15 is greater than 12 or 17? No, 15 is not greater than 17. So this is a valid ACBT, but the ordering is not right. So we cannot call it a max heap or a min heap. So this is not valid. So guys, let's see if this is a valid heap. First, we need to check if this is ACBT. So this is a valid ACBT. Why? Because all the levels are completely filled and we started filling from left to right. So next, we need to see if this is max heap or a min heap. This is a max heap. Why? Because every parent node is greater than its child. Let's see how. 50 is greater than 40 and 44, 40 is greater than 20 and 30, and 44 is greater than 42 and 43. So we can call this a max heap. So guys, that's all for this video. In the next video, I'm going to tell you how to do insertion in a heap tree. In case you haven't subscribed to my channel, please do subscribe because I'll be making a lot of videos on data structure and algorithm. This is AJ signing off.